Hey everybody. In class today we started talking about slope, which tells us the steepness of a line. Tonight we're going to get a little more practice with that concept. Remember, anytime we have 2 points, we can find the slope between those 2 points by looking for the vertical change and the horizontal change. Remember, the slope equals the rise over run, which is another way of saying the slope equals the change in y over the change in x. And another way that we represent this is with this symbol. That's a delta, and it represents change. So we say the change in y and the change in x. So it's always the change in y, the vertical change, divided by the horizontal change. Remember, in class, we looked at 2 different ways to do that, to find the slope. We talked about the rise over the run, the vertical change over the horizontal change from a graph, or we talked about calculating the vertical change and the horizontal change using the slope formula. Tonight we're going to practice a few more problems using those 2 methods. Let's look at our first 2 examples here. We have A and B. In example A, notice we have 2 points on our graph. We have -4, 2, and then we go up to 2, 6. Now our graph is headed in the positive direction. It's going up from left to right, so we know we're going to have a positive slope. Now, I actually have the rise and the run on this graph already. The rise is 4 and the run is 6. So if we were going to calculate our slope, we know that we're looking for the change in y over the change in x, or the rise over the run. So in this case, I have 4 as my rise, and I have 6 as my run. So my slope is 4 over 6. Now remember, I always want to simplify my fractions. So 4 over 6, I can divide both of those by 2 and get 2/3. So my slope, for example A, is 2/3. Example B, now we have a line going down as we go from left to right. So since this line is going down, as x increases, we know that this is going to be a negative slope. And we see, as we go from 3, 5 to 6, -1, our rise is -6 and our run is 3. So -6 is our rise, our run is 3. If we simplify that, -6 divided by 3 is -2. There's our slope. Now, some lines might look different than others, but we do them the same way. These 2 examples aren't diagonal, but we can still find the slope by finding the rise over the run, or the vertical change over the horizontal change. Now, in example C, I don't have a rise here. I actually start at 4 in the y direction, and I end at 4. I don't go up or down at all. I just go straight sideways. Because I go neither up nor down, my rise is 0. And my run goes 1, 2, 3, 4, 5, 6. I go to the right 6 spaces. Now 0 over 6, when I simplify that, I am just going to get 0 as my slope. In example D, we have a little bit of a different situation. Here, my rise is 1, 2, 3, 4, but I have no run. I'm not going to the right, I can't go to the left, I'm just going straight up and down. My run in this case is 0. Now, this is where a lot of people make mistakes. We can't do 4 divided by 0. A lot of people think this is 0. But if you try to divide by 0 in a calculator, you're going to get an error. We actually say that this slope is undefined. There's no number that can represent this slope. It has no definition. It is undefined, this slope. Just like we saw in our last 4 examples, we can learn a lot about the slope of a line just by looking at it and what direction it goes in. If the line is going up as we go from left to right, we know that the slope is going to be positive. If the line is going down from left to right, we know it's going to be negative. This will always be negative if a line is going down from left to right. A horizontal line will have a slope of 0. It's not going up or down. And a vertical line will always have an undefined slope because the run on a vertical line will always be 0. Because the x direction isn't changing at all, we actually don't have a number that can represent this. We just say it's undefined. Now, when we don't have a graph, we have to use a different method to find the slope. Remember, we can use this formula, m equals y2 minus y1 over x2 minus x1. Now, a lot of people get these numbers here confused for exponents, but this isn't y to the second power. When the when the 2 is down like this instead of up, this just means the second y value. y1 means the first y value. If we want to label our points here, we can show that our first point has an x and a y, and because it's our first point, that's x1 and y1, and then we have x2 and y2. Remember, every point has an x and a y. So now if we put this in our formula here, we have -3 minus 5, the second y value minus the first y value, and we have 1/2 minus 9/2. Now all we have to do is simplify. -3 minus 5 is -8. 1/2 minus 9/2, that's -8/2. So we're going to want to simplify that. That's -8 over -4, and -8 divided by -4 gives us 2. So our answer, our slope, for example, E, is 2 between those 2 points. In example F, we can do the same thing. We want to make sure we know each variable, x1, y1, x2, y2, first point and second point, and now we just do our subtraction. -2 minus 2 and 5 minus 5. Now -2 minus 2 is -4. 5 minus 5 is 0 though. So this is actually going to be an undefined slope. So we know, if we graphed this, we know that this would be a vertical line. Example G here, you can do the same thing. x1, y1, x2, y2, label our points, label our coordinates, and use the formula. 4 minus 4, -3 minus 0, that gives us 0 over -3. Now this one we can divide. We get 0. That's our slope. We know that this is going to be a horizontal line just from the slope. And our final example, we have h, x1, y1, x2, y2, and now we just use our formula. y2 minus y1, x2 minus x1, and we get -10 over 5, which equals -2. So without even graphing this, we know that our line is going to be going down from left to right. Those are all of our examples for tonight. Go ahead, complete your notes. Don't forget to submit them through Canvas, and I will see you all tomorrow.